Good morning, student. This is Nagar Miravali. Welcome to online class of Mathematics B.sc third year. In this video, we are going to start the concept vector space. In this section, we are going to learn about the basic concept about the sets. Next one, explanation about the operations. Next one, basic properties. Okay, students? Okay. Okay, students. Now the topic name is vector space. Vector space. So this is the first unit. Before going to do the vector space, now I am going to discuss about some basic concepts. We know that the sets, okay, basic sets first of all. Already we know that the basic sets. We have the basic sets, they are natural numbers and whole numbers, next integers and real numbers, okay, natural numbers. Natural number set. This is n. It is denoted by, they are starting with 1, 2, 3 up to and so on. Next one, whole numbers. Whole numbers set, that is denoted by W. So this is more one element extra of natural numbers. So this is next one, integers. Integers set. This is denoted by Z or I. Okay. So they are containing the negative values and positive values. That is -2, -1, 0, 1, 2 up to and so on. Okay. Next one, rational numbers. Rational numbers. This is denoted by Q. That means they all are of the form P by Q form, such that where P comma Q are the integers. Okay, integers. And one more thing is the denominator we have taken, that will not be 0. Okay, this is about the rational numbers. Okay, next one, after that, real numbers. Real numbers, the set of all real numbers, that is denoted by R. This is all the union of rational numbers and irrational numbers. That is, this is the rational number system and union with irrational numbers, that is Q complement. So here real rational numbers means the number which is of the form P by Q is called the rational number. Now irrational numbers means the numbers which are not convert into the P by Q form. That means the numbers which cannot be expressed in the form of numerator and denominator, they are called the irrational numbers. Now if you want to take the real numbers, that means real numbers is the union of rational numbers and irrational numbers. Okay, so that is the concept, that is the real number is the rational numbers or irrational numbers. Okay, union of these two numbers. Okay, they are the basic sets. And next one, note point, our fundamental operations. Okay, what is that? Note point, fundamental operators. So we know that by taking any two numbers, that means the any two numbers means any numbers we have taken in the before sets, that means either natural numbers, either whole numbers, or integers, or rational numbers, or real numbers. Okay, if you take in any two numbers, for example I am going to take 2 and 3, then what we are going to do here? So are you guess anything? Here we are going to do, by taking these two numbers we can add means plus, or we can subtract, that is 2 minus 3, we can product, that is 2 into 3, we can divide. Okay, so we here we have done 4 operators. Okay, so they are called the operators or operations. Okay, they are called the fundamental operations. Okay, what are the students? So they are called the fundamental operators. So in mathematics system, the fundamental operators, fundamental operations in mathematics are plus, minus, into, divided by. Okay, they are the fundamental operators. Okay, students, now sets, Cartesian product. Now I am going to discuss about the Cartesian product. Cartesian product means first we need to take any two sets. Let capital A and capital B are two sets, two non-empty sets. Non-empty sets. First we are going to take the two non-empty sets. A set and B set we have taken. Already we know that the order pairs. Order pairs means by taking two numbers, we can arrange it in the form of brackets and separated by the commas. This is called the order pairs. So in this order pair, here we have used two elements. What are they? A element and B element we have used here. So how many elements we have taken? Two elements, A and B. So if you take in the first element A in the set A, second element in the set B, now this is called the element. The total order pair A comma B is the element in the Cartesian product of A and B. So Cartesian product of A and B is denoted by AB. Now element, this is Cartesian product of A and B can be taken here. Now the order pair, what is that? A comma B. This is the element in A and A cross B. Okay, Cartesian product of A and B. Remember students, here there is only two relations between an element and a set. Suppose I have taken a set here and element is A. So remember students, one thing, already we know that element can be denoted by the small letters and set can be denoted by the capital letters. Okay, now there will be two relations between an element and a set. Suppose if you take an element A is in the set A, so this can be written as simply A belongs to A. Okay, what is the relation between the set and an element? Element is in A or not in A. Okay, if an element A is in the set A, it is denoted by simply A belongs to A. Suppose A is not in A, this is denoted by A does not belongs to A. Okay, this is the relation. So only belongs to and does not or does not belongs to are the only relation between the set element and set. Okay, yes students, if you take any element, something X is in A, that means X is the element of A. No need to write like that. Simply it is enough to write X belongs to A. Okay students, you have to remember this one concept. Okay, now Cartesian product. So here Cartesian product means Cartesian product of the two sets means that is also a set. Cartesian product of the two sets means that is also a set, but that set contains the set of all order pairs. Okay, the order pairs can be formed by taking the first element in the first set and second element in the second set. Okay, non-empty set. So here we have taken let A and B are the two non-empty sets. Now Cartesian product N product of A and B is denoted by A cross B. So read as A cross B, not this is A into B. So Cartesian product of A and B is denoted by A cross B, and it is defined as A cross B. So what we say that A cross B is the set that contains all order pairs. How many sets you have taken? Two elements, two sets you have taken. That's why you need to write in the bracket two elements A comma B. But here the first element that is belongs to the first product set. Second element is belongs to the second product set. That is the concept, students, you have to remember. Okay. Now A comma B such that where the first element where you have taken the set capital A, the second element B is the element in the B. Okay, this is the Cartesian product of the two sets. Okay, students, we have to write this one properly. Okay, suppose here note points, some note points here you want to take. Here A cross B meaning is the set of all elements A comma B such that the first is A belongs to A, second element B belongs to B. And the same as B cross A. This is also of the form A comma B, but what is the first element you have taken? A. That is belongs to the first set. The second element belongs to the second set. Okay, students. Now in the same way, where A is the first set element, B is the second set element. Okay, student, this is the concept. Okay, next one more thing is A cross B is not equal to B cross A. Okay, this is the note point you have taken. Now I am going to use the properties here by using plus and into. Already we know that in the previous year the closure property, associative property, identity property, and commutative property and inverse property. Okay, so here also in this section we are going to discuss about these properties. Okay, students, first I am going to take the operators here. Addition, it's here multiplication, addition and multiplication. Okay, before going to do here, first of all, okay, let A, B, C are the elements in a set S. First we have to take this one. Three elements I am going to take here. Now by using the addition I am going to write the each property here. First one, a property, property Closure property, first one. Closure property. So here with respect to plus operation, the closure property is the for any two elements a comma b belongs to S. Now if you operating a comma b with plus, now the result element is also belongs to the set S. This is the closure property with respect to addition. Here addition means plus, multiplication means dot or into, okay, dot or into, whatever may be. Next one, a cross b. Now in the same process with respect to multiplication, if a comma b belongs to S, then a b belongs to S. This is the closure property. Second one, associative property. Associative property. Here a comma b comma c belongs to S. Now we have to write a plus b plus c is equal to a plus b plus c. This is called the associative property. Here also we are going to write here with respect to dot a into bc is equal to ab into c. That means with respect to addition you have to use the plus, with respect to multiplication you have to use the dot. Next one, identity property. Identity property means, first of all you need to take an element a. Suppose by taking this element we can add some element here, you will get the answer a. So observe students, what the element you have to write in the place of e here? Have any idea? What is that? If you add some element to the element a, you will get the same answer a. Then what is the element you have to use here? In the place of e you can use 0. In the place of e you can put 0, then you will get the same answer. Okay, in the same process, this is called the identity element. Okay, where e is equal to 0 is the identity. Next one, coming to the multiplication property, we are going to take the element a and multiplying with some element, you will get the same element. So suppose I have taken an element a. By this element I am multiplying with some element, you will get the same answer. That means here what you should write in the place of e, what you can put here, a into something is equal to a means what is the e value here? 1. So in the same process e into a is equal to 1, where e is equal to 1 is the identity in S. Here also identity in S. Okay, that is you are going to write. Next one, okay, next property is inverse property. Before going to talk about the inverse property, first you need to know about the identity element. What is the identity element here? 0. So now by taking an element a, you can add here some element, you will get the answer identity. Okay, identity means here 0. So if you take an A, what is the added element here in the bracket, you will get the 0 answer. So what is that element? Minus A. You can take A plus of minus A, you will get the answer identity minus A. In the same process, minus A plus A is equal to 0. Okay, so identity element is the 0. So now output will be 0 here, where minus A is called the additive inverse element in A, in the set S. Okay, here also A into some element is equal to 1. What is the sum element here? You can write here 1 by A. That means it can be written as A inverse is equal to A inverse into A is equal to 1. Okay, where A inverse is called the inverse element in S. Okay, next one. Next element, next property, commutative property. Commutative property. Commutative property is like that. Let us take any two elements, that is A plus B is equal to B plus A. Okay, A plus B is equal to B plus A. This is the commutative property with respect to addition. Next one, with respect to multiplication, A into B is equal to B into A. This is the commutative property. Next one, distributive property. Distributive property. So distributive property is the combination of identity property, combination of plus and minus. So here we are going to take any three elements here. Let A comma B comma C belongs to the set S. Now then the first one, A into B plus C is equal to AB plus AC. This is called the left distributive property. Left distributive property or left distributive law. Second one, B plus C into A is equal to BA plus CA. This is called the right distributive property. Okay, students. So they are the major properties you have to learn here. So what are the properties here? Closure property, associative property, identity property, inverse property, commutative and distributive properties with respect to plus and with respect to minus. So students, you have to read these properties carefully and verify the properties once again. Okay students, these properties are very important for us. Okay, now we are going to discuss about the simple operations definition. Okay, so here we can use the closure property here. Closure property, so this is also, this property is called the binary operation property. Okay, this can be written as simply, so these all operations, that means plus or into, they can be used any between any two elements. That means Suppose A, B. If you want to add them, you can write A plus B. This can be written as simply, this is the original definition is addition of A comma B. In the same process, if you want to multiply these two ones, A into B, this is called the product of A comma B, product of A comma B. They are the original definitions, these two ones, but we can write simply addition of AB like A plus B, multiplication of AB like A cross B. So that means here plus and into are the two, both are the functions here. Okay, that means like that. That means here plus is a function from the set this one, where you have taken A comma B order pair, that is in the Cartesian product. Suppose S cross S, this is a Cartesian product. If you want to add 2 plus 3, you will get how many answers? Only one answer, that will be 5. 2 plus 3 answer will give the 5 always. No another answer will be there. Okay, so that means that is output will be the only single element. So that is the operation. So here binary operation is a mapping from S cross S to S. Okay, in the same process, into or dot, they are also the functions from the S cross S to S. Okay, okay students, binary operation is the mapping like that. Okay, S cross S to S, and dot is the S cross S to S. This is the most important notation, you have to note that. Okay, means binary operation or closure means simply we can write here, let S be a non-empty set, then the mapping. Suppose if you taken either plus or minus, either plus or dot, that value can be star. S cross S to S is called a binary operation, where in the place of star you can put either plus or into. Okay, so maximum we can take plus operation and into operation. Okay students, this is about the basic concept. Now I am going to explain the definitions of a ring here. Already group is there. First group we have studied in the previous class. So group means let S be the non-empty set, and an operation star be an operation with the properties on S. First one closure, second one associative, third one existence of identity, fourth one what is that? Inverse property, inverse. Okay, so is called a group. It is denoted by group G star. Sorry, it is denoted. What is the set we have taken here? S star. S star is a group. Okay, now I am going to write the example for the groups. Example for the group Z plus is a group. Next one Q plus is a group. Next one R plus is a group. Next one the system of complex numbers with respect to addition. This is the group. With respect to dot operation, the groups are Q dot is the group, R dot is the group, C dot is the group. They are the group. Groups with respect to addition are these four are the groups with respect to addition. They are the groups with respect to multiplication. Next one, Abelian group. Abelian group. Abelian group means a group with a commutative property. Okay, simply we can write a group with a commutative property is called the Abelian group. Abelian group examples are they all are the example for the Abelian group. So they all are the example for the Abelian group. Next one, ring. Ring definition. So here two operations we have to take. Let R be a non-empty set. So here we have to take the set. Here R means R, that is not the real number system, any set. Here I am going to take let R be any non-empty set. Any non-empty set and plus comma dot R, two operations on S on R if satisfying the following properties is on S. Following properties on S. First one, R plus is an abelian group. Second one, R dot is a semi-group. Semi-group means closer and associative. Okay, closer and associative. Okay, so that is next one. Third one, distributive properties. Distributive properties. Okay, students. So these three properties can be satisfied by the set R with the plus and dot. Then we say that R is a ring and it is denoted by R plus dot ring. Okay, this is about the ring. Now already we know that the example of the rings are examples. So group conditions with respect to are Z plus dot. This is a ring. Q plus dot is also a ring. R plus dot is a ring. C plus dot are the ring. They are the basic rings example. Okay, students, you have to note them properly. Next, we are going to discuss about the field definition. Okay, now I am going to discuss about the field. F-I-E-L-D. Field. Field means a commutative ring with unity. Okay, simple definition is a commutative ring with unity. Unity is called a field. Okay, that means, or simply another definition is a non-empty set F together the operators plus and dot is said to be a field if first one F plus dot is a ring. First, this is the ring. Second one, commutative. So what we say that commutative ring with unity. In this one, ring is over. Okay, ring. Next, commutative. Commutative means already with respect to plus we say that Abelian group. But commutative means here we have to use with respect to dot. For simple definition is A B is equal to B A. That means A into B is equal to B into A for all A comma B belongs to F. If you have taken any two elements in the F set, now you can product them AB and also BA. Both have the same answer. Next one, third one, unity element. Unity element means multiplicative unity. Multiplicative unity means unity element means a commutative ring with unity. Sorry, the definition is a commutative ring with unity is said to be a field. Sorry, is a simple definition. Unity is said to be a field if every non-zero element if every non-zero element have a multiplicative inverse. Multiplicative inverse in F. Okay, this is the definition of field. So that means here commutative ring with unity. Unity means here I am going to write unit element, that is identity element. So that is 1 belongs to F. This is the multiplicative unity. Okay, next one. Fourth property is every non-zero element. For a non-zero element, there exists its inverse element in the set F such that A into A inverse is equal to A inverse into A is equal to 1. Okay, this is the property. Commutative ring with unity, and also every non-zero element have the multiplicative inverse. This is the definition of the field. Now the field examples are just three fields are there, that is q plus dot, this is a field. Next one r rational numbers, real numbers, r plus dot is the field. Next one c plus dot, they are the field. Okay students, so they are the major definitions of the basic concept of the vector space. Okay, first you have to read them properly. After that we can start the vector space topic. Okay, so first you have to learn these these definitions also. So what are the definitions we have taken here? Basic sets, next one Cartesian product, next properties. Properties means there are mainly five properties are there: closure property, associative property, identity property, inverse property, commutative property. They are the five major properties. After that, one property is the distributive property. This property will be repeated with respect to the plus operation and minus dot operations. Okay, next one you have to remember that the closure property. Closure property is the operator, that is a function from s cross s to s. This is the main important one. So that can be used in the vector space definition also. So next one, the major definitions already you have learned in the in the degree second year concept, group theory. So in that one, group theory and ring theory, in that one just I have here I have remember that groups and abelian groups, next rings, next one field. Okay, so they are the definitions you have to remember. Once again you note that these properties. After that we will continue the main definition of the vector space. Okay students, I hope you understand this concept. Okay students, we will meet in the next video. Okay.